20
Hello,
minutes,
everyone.
20 to 30 minutes later.
That's quite all right. So I am giving a rerun here of a talk I gave at IETF a couple of weeks ago. And this is me as the chair of the Trustworthy Workload Identity Special Interest Group at the Confidential Computing Consortium. And this is the output of this work, and was actually presenting a draft that was submitted to IETF with Yogesh and Hank. So both of whom are here today. So I will have to move quickly because there's a lot of content here and unfortunately not a lot of time, but here's my LinkedIn. I'm happy to answer questions and engage with all interested parties. So I also have to say, so in my daytime job as a senior principal architect for JPMorgan Chase, I'm required to say that these opinions are not representative of anything my employer thinks. So, all right, with that disclaimer. While I still have your attention, this is what this talk is about. This is about business. This is about money. And this is about making confidential computing specifically deployable at scale. And I want to make a case that we have not been following a most business-friendly path. I want to explain why and what can be done about it. So my talk really has two parts. I want to frame a business problem first, and then I want to go into more technical details of what can be done about this problem. So the platitude is that the network perimeters are dissolving. They are much less effective than they used to be. And yet, we want data protection, what I would call a whole of enterprise concern. This means on every workload and also while at rest, in transit, and in use. And this is where confidential computing comes in, because the first two, I think we got pretty much handled over the last 20, 30 years. And I also want to draw your attention to this interesting fact. Most data exchanges are between pairs of workloads. Very few exchanges are between some user of a system and some endpoint. Most of it is really, and especially in cloud applications, this is going up by probably another order of magnitude between serverless and step functions and queues and compute units and storage units, etc. So you want to secure data in all of these scenarios. And when your network perimeter is dissolving, you will find that the way to mitigate this is you want to assign identities to your workloads. And with identities come credentials, and with credentials come keys. And those keys can be used to secure various exchanges. Like my employer has on the order of 7,000 applications. You're not going to be able to uplift them all to confidential computing overnight. So for the foreseeable future, you're going to have a significant mix of both confidential and non-confidential, or what I call legacy workloads. And if we're going to issue identities to all of them, then they need to be harmonized. It's not possible in a large enterprise to issue one type of credential to confidential workloads and another very different type of credential to non-confidential workloads. Ultimately, the relying party needs to deal with things, and especially as the workload changes, maybe I started running something in confidential environment, my relying party should not stop working because of that. And all solutions that succeed at scale, and this is specifically what I want to talk about in this talk, is how to make confidential computing at scale. They need to be manageable and deployable, so we'll talk about what that means. And the case I want to make is if you want to make something like this manageable and deployable, you have to start at the relying party, and then you have to walk your way backwards. Now, the next thing I want to talk about is this thing I call relying party empathy. So relying party empathy is really how do you ease the job of a manager of a service that is authenticating and authorizing workloads that attempt to extract data from it or attempt to make it do work. And the key point here, now the very key point, is you have an authorization policy on your relying party, basically saying this is who I'm willing to talk to. And that authorization policy needs to be stable for an extended period of time. When I say extended, I really mean years or decades. So once you set the policy, it's kind of set it and forget it. In most business environments, the business itself does not change. So I will going to be making an example here that I call a payroll, some sort of database, right? And it contains information on, salaries, locations, etc., of various employees, and there are different applications that may be accessing it. So that's my relying party, is this application that needs to service requests from all over the place. And the other fact of life is change, and both your software and your hardware will be upgrading, and then some upgrades will fail, and there'll be a downgrade or like a rollback. So you need to keep a stable authorization policy on the relying party, even as that happens. So both software changes and hardware changes. And further, actually, before I go to the next point, normally in an organization, especially a large one, you're going to have some on-premises data centers, you're going to have some clouds, you're going to have some personal use devices, etc. You're going to have a lot of different things. And the people who manage the hardware and the people who manage the software, they are almost always different people. So somebody may decide we need to upgrade some hardware in our data center. Maybe we're, removing Intel servers and installing AMD servers, or maybe just rolling, just deploying new firmware patch to some of our servers. And in some cases, your hardware manager is your cloud service provider over whom you have basically no control. So all of that is a fact of life, but there is another fact of life in the authorization policy that is stable, that's long-term stable on your relying party. Will be like, well, if you're going to access my payroll database, then you better be the payroll application. If I'm going to serve you information on senior executive compensation, then you need to be cleared for highly classified information. Whatever that means, somebody else determines what that means. It's not the relying party that determines that. Or maybe there is one, there is some, maybe I want to know that the workload has been cleared to access PII, and then I can give it the phone number and the address of an employee. And maybe the employee is located in Germany, so their data must be processed in Germany. So these are the high-level claims. These are the sort of the bread and butter of a relying party. So my next point is oh, and I also want to mention, relying parties are also clients of other workloads when it comes to workload identity. So it's very, very rare that a workload is the sort of the terminal entity that will not authenticate to anyone. Even if you're a payroll database, you're still going to be writing to some kind of logs. So you also need to have your own workload identity, both for outbound authentication and for inbound authentication. So maybe there's mutual TLS going on. So all workloads are always engaged in presenting their workload identities for to both other clients and as clients, and being so clients and servers. All right. So when you come to RATs specifically, my claim is that it lacks relying party empathy. So what I mean by lacks relying party empathy is that as a rule of thumb, if you are putting something into the and I'm assuming here that everybody here is familiar with the RATS reference architecture, but a very quick recap: the attester presents evidence to a verifier. The verifier responds with attestation results, and the attestation results contain something that is then destined for some relying party. And my claim is if you put anything into attestation results that will break the long-term policy on a relying party, then you lack relying party empathy, right? So I'm sure there are scenarios in which this works well, but in an enterprise that requires the stability of authorization policies, it will not. But here I just quoted some kinds of thing that is very likely to break. And this is not cherry picked. This is straight up quote from the text of both the RATS charter and the latest RC draft. Okay, so how do we imbue RATS with relying party empathy? So first of all, I want to disambiguate what may become a terminology confusion. So a relying party here is the recipient of a workload credential. And it may or may not be, and we'll look into some technical details here, the same as the RATS notion of relying party as the recipient of attestation results. So RATS has a relying party as the entity that receives attestation results. And here I'm saying the attestation results may require an additional transformation before they can be presented to a stable relying party. So when I say relying party from this point on, and I mean the real world payroll database type of relying party, not the RATS relying party necessarily. So I'm introducing a new architectural building block that I call a claims mapper. So the claims mapper is an architectural building block. It's not a service. It's not a procedure. It is something that performs a function, and however it gets the embodiment, being an architectural building block, may be very, very different depending on how you structure your system. But the function of the claim mapper is it receives some inputs and it produces some outputs. The inputs would be the evidence in some cases, attestation results in some other cases, but that's some information about the workload. And that is fragile. That can change with a hardware update, with a software update. But what it emits is stable. The workload identity, payroll database, and additional stable claims like located in Germany type of thing. All right. So, and then we'll talk about how this claim mapper gets integrated into issuance flows that result in workloads obtaining credentials. And workloads here are specific confidential computing workloads. So we will be mapping at some point in time, we'll see that during the credential issuance, low info level information will be mapped into the stable information, business-centric information. So there are two parts to trustworthy workload identity. We'll talk about the credential key. That's public. And by the way, again, under some architectures, the credentials are also secret. This is not here. So like bearer tokens are out of the loop. We're not considering them here. The credential key here is, that one is actually secret. So it's an asymmetric signing key. Only authorized workloads can see it. And it's not the whole credential, just the key, something to produce as proof of possession with the associated credential. And the credential is like an X59 certificate or a whimsy workload identity token, or it could be anything else, but the properties are that it's public. You can hand the credential to anyone. You just can't use it without the key. It will contain the public portion of the credential key. All credentials always are generated by some kind of credential authority. So it could be a CA, it could be some security token service, but something you trust to issue credentials. And it will require proof of possession of the credential key to use. Now, we'll talk about the credential is always generated at the credential authority. It's not always received from the credential authority because there could be someone intermediating that exchange, as we'll see in a second. But you get these two parts, so I hope that's clear. And now, what are the pivots? Well, first of all, is where do you get your credential key from? In some scenarios, and I will actually argue in fairly few scenarios, the key is going to be self-generated by the workload instance, and then it's going to be certified by remote attestation. I will explain why I think that's actually not going to be the majority case, but it certainly needs to be supported. And in the other case is you get your key from some kind of a key store that is contingent on the workload successfully attesting itself. And why I think that's more common is because horizontal scale out is very, very common. And effectively, if every workload in the enterprise, no matter how short-lived, no matter how horizontally scaling, always generates and certifies its own key, it's like just basic engineering reason. You're going to blow your credential authority out of the water. It's going to put unacceptable load on the credential authority. But both scenarios need to be supported. Now, the second pivot is where does the workload get its credential from? As I mentioned already, all credentials always generated by some credential authority. But depending on the topology, as we'll see shortly, the workload may get it from the verifier, so I guess as parts of our attestation results, or may get it from the credential authority directly, much like you do with a certificate. When you do a CSR, you get back an X59 cert, or with an STS. Or for the horizontal scale-out case, it's the workload owner. Again, credential is public. Anybody can give it to you, right? So the trick is then being able to obtain the key for it. Okay. So these are the pivots. So you get a 2x3 matrix. that I call credential acquisition mechanisms. I haven't come up with an elegant name to name these, but I named them after the topology. So it will become clear that what they are. So for instance, the one on the top left, WVCA, just means the workload talks to the verifier, which in turn talks to the credential authority, right? The one on the bottom right is the workload talks to the verifier first, and then the workload talks to the key store second. That's why the long hyphen. So that's notation, but you don't need to remember it because in the next 4 slides, I will illustrate each one of these credential acquisition mechanisms. I also want to make it clear that it's not necessary to implement all 4. I'm just trying to basically show all possible ways in which this can happen. And if I missed one, shoot me a message, and maybe I'll amend the text. So nothing is cast in stone thus far. So let's go through them one by one. So this is the one where the workload talks to the verifier, and the verifier invokes the credential authority on its behalf. So what you will see is in steps 1 through 3, you generate some kind of credential key on the workload. And again, because the workload is running in a confidential computing environment in a T, the private key is protected by the guarantees of the workload. And then the workload creates a credential request, including the key proof of possession. That's pretty much standard crypto. And then you create evidence. That's your quote. And in the evidence, you supply the credential request in addition to all the measurements of the software and all the measurements of the hardware and all the good things you already know about. So then it goes to the verifier and basically says request attestation. And here's my evidence. And the verifier praises the evidence. And this is where the claims mapper is invoked in this scenario. You'll see claims mapper is invoked in different ways depending on the workflow. But the claims mapper will basically take the evidence, map it into claims about the workload. And from there, we go to the credential authority. We request the credential. The verifier does it on the workload's behalf. The credential authority will create and sign the credential with the claims given to it, will return the credential, and then the credentials get packaged in attestation results and given back to the workload. So now the workload received credentials in these attestation results encoded and can go talk to some relying party. But now the credential has stable claims, not what would have happened under, frankly, most of today's verifiers. So here's another slightly longer list, but this has to do with the nonce and freshness in the beginning. So we can skip over that. That's a standard fare. But you will recognize the pattern. The workload creates a credential key, creates a key proof of possession, creates a credential request. But now, instead of talking to the verifier, it goes talks to the credential authority. And it says, request a credential. So much like you would submit a CSR to a CA. And in this case, the credential authority still needs to go talk to the verifier because somebody needs to appraise the evidence and compute some attestation results. And here, this is the off-the-shelf verifier that gives you what I call fragile attestation results. But no worries, because when the attestation results come back, the credential authority can invoke the claims mapper on these, produce stable claims, create and sign a credential with those claims, and again, return the credential to the workload that is, again, stable because all the fragility has been hidden. So this is the second one. And again, I'm going fast and I apologize. You'll probably have to watch the recording later or shoot me an email again. Happy to discuss this, but I have to fit it all in like 20 minutes. So pretty much have to storm through this. All right, so we have 2 more. In this case, the workload talks to the verifier first, gets back some brittle attestation results. No relying party wants to hear these because they will just break with every hardware upgrade, as I mentioned. So it needs to make another round trip. In this case, the first round trip is to the verifier. The second round trip is to the credential authority. The credential authority invokes the claims mapper. Again, creates and signs the credential, but the thing that is returned in step 11, the last step here, is once again a stable credential. All right, one more. This is the one I believe is going to be used most. And again, because it handles cases where workloads are short-lived, and it handles cases where credentials are horizontally scaled. Sorry, I lost my train of thought there for a sec. Here, the claims mapper is invoked first. We're basically saying, look, we understand what the stable claims for the workload are going to look like, and we are going to create some key release policy based on anticipated attestation results. So the workload owner has to do this work. And it basically needs to say, here are the claims, and if these attestation results are presented to a key store, then the key store will retrieve the key. It then proceeds to the key store and basically says, hey, why don't you go create a key? I don't want to see the key. I just want you to create it, giving back some key ID or the public key over it, for whatever. And here's the key release policy. If you see these attestation results, go retrieve, allow the requester to retrieve the key. And then, again, without seeing the key, but talking to the key store, we can create a credential request that gets signed with the proof of possession. And with that, we can go to the credential authority and say, all right, create this public credential, just give it to me. I will be handing it out to everybody else, right? So in the bottom of the left diagram here, the workload is provided with credential key. You will notice that this is how containers work today. We put credentials on a volume, containers mount the volume, get the credential and the key out of the volume, and off to the races they are. But in that case, these credentials are kind of like bearer tokens. If you steal that volume, if you got that credential key and the credential, there is no proof that the workload is in fact protecting the key and is in fact running confidentially. But over on the right, the workload then generates not a signing, but an encryption key. And it will request attestation from the verifier, including a public portion of the encryption key. And the verifier will appraise the evidence, return the attestation results. These can be brittle. That's perfectly fine. But they just need to map to the key release policy on the verifier. So then these attestation results get sent to the verifier, which checks them against the key release policy that the workload owner set originally, and will return the actual key. But of course, it needs to be encrypted, so only the workload can see it. And see on the bottom, the workload can decrypt the credential key, and off to the races we go. So we were able to deliver the credential key to each workload. All right, so some known security issues. Well, you have to trust all the components here. You need to trust your verifier, you need to trust the credential authority and the key store. You should probably use TLS between the pairs of these. And this is full security analysis is needed because we could be looking at replay and relay and other attacks. We need to understand that we need to so some future work needs to be done here to ensure that we're not leaving something. And one known nasty issue is if you just live migrated your workload from Germany to France, and yet your credential still says I'm running in Germany, we need a way of invalidating such a thing. And we haven't thought that one through fully just yet. So you need to understand sort of you're playing with a little bit of danger here. Some links, then again, you don't need to copy them. The deck is provided and you should be able to download it. But we have a charter for our trustworthy workload identity special interest group at the consortium. We have some definitions and requirements, which are much richer than what we're going through here, because we also talk about things like provenance and being able to do deeper inspection of, why was the credential issued and whatnot. We are started work on the reference architecture. There you'll find a link to Google Docs and nothing else, but it's an evolving document. And there is a draft that was presented at the IETF, which you can also see, which has less nice ASCII art than is possible in PowerPoint. All right, so that's my presentation. Thank you for your attention. I don't know if we have time for questions, but.
So thank you very much, Mark. Very interesting. So I had one, I won't say really question, but clarification. So when, and I can see a couple of questions, so we'll come to those, but we'll try and keep the time short.
Yeah.
My question was really one of understanding. So when you talk about a workload identity being effectively stable over, let's say, decades,
yeah,
presumably what you're saying is something. As an example, I have a COBOL workload which was once on a mainframe and I've now moved it to a Unix server, and then later on I move it to a Unix server that has a different CPU architecture, but you still want it to say the same things about itself to the business. Is that broadly
that is basically correct. The decision of what to trust is not made by the relying party. It's made by the policy administrator, and the policy administrator is trusted to decide And by the way, you're not even going to have one policy administrator, right? You're going to have perhaps 3, right? So you may have a policy administrator that says, this is what constitutes acceptable hardware in our business, right? This is not every relying party in your enterprise with tens of thousands of people and 7,000 applications is not going to be making that decision independently. That's a centrally made decision. And then you may say, well, say we measure the workload by this is what operating system it's running on, but plus what custom code was added onto it, right? So again, the people who say what's a valid operating system, a valid patch level, are not the same people who decide what's the latest version of the payroll application. So you basically need to do a level of indirection here. The relying party will simply say, look, if your credential has these claims in it, I'm just going to trust the issuer of the credential. The issuer of the credential, your credential authority, now needs to in turn trust something else. And by the way, so another key aspect here, that this is very, very important. In some cases, your credentials will not be issued to a confidential workload. They'll be issued to a legacy workload. And again, the decision of which workload gets which credentials is not made by the relying party, right? So this is how you gradually transition from the world we live in today, that's chock full of bearer tokens and God knows what, to a world where your credentials are, in fact, strongly bound to the workload instance.
Okay, I think I understand. Thank you very much, Mark. So, Osama, but fairly quickly, please, because time is very short now.
Sure. Yeah, in the REST meeting also, there was very short time. So anyway, so very quickly. So the designs that you should have relay, replay, and diversion attacks that I talked about. And separate from that, I think there needs to be a mapping with the remote attestation architecture, like RAT's terminology. That's something I found missing. Thanks.
Okay, I mean, I think work in progress, that's probably understood. So thank you very much, Mark. Really good presentation.